the ocean. It covers more than 70% of Earth's surface. We know the ocean is home to things like coral, plants, and bountiful marine life. But it holds other things too, like clues to our past, present, and future climate. Whether the Indian Ocean to the west of Malaysia, the Arctic Ocean off the coast of Greenland, or the Atlantic Ocean that separates North America and Europe, the ocean connects every region of the world through climate. But how much can be revealed about the global climate from just one of these areas? Let's find out with Dr. Diane Stanitsky and Commander John Adler of the National Oceanic and Atmospheric Administration, or NOAA.
Welcome to California, Argos. We are here in lovely Santa Barbara, where we have this beautiful fog, and I anticipate it will lift before the day's mission is over. So today we're going to be going out on board the RV Shearwater, which is the Channel Islands National Marine Sanctuary vessel, and we'll be exploring ways to help us understand more about the climate of this region, because it really is a unique location.
I'm Commander Adler, and I'm a navigator by day and a scientist by night. I work with NOAA, and as you see, I'm in uniform, so I'm a NOAA Corps officer.
Adler and Stanitsky are not only climate experts, but they're also husband and wife, a true science power couple. They'll be leading you on your expedition, where it's your goal to investigate the relationship between the atmosphere and the ocean and explore how both influence climate. To accomplish your expedition goals successfully, you will need to describe how the ocean and ocean currents affect climate, explore patterns of ocean currents, recognize what an El Niño is and how it influences climate. Climate is the average weather conditions for a location over a long period of time. Since the ocean and atmosphere are so interconnected, a lot of answers to our questions about climate can be found underwater. And to get those answers, the Argos must use technology to do some things that humans can't.
We are here in the Channel Islands National Marine Sanctuary, and we're ready to deploy a drifting buoy. Are you set to do that?
Yes.
All right. Lisa and Sarah are going to be working hard with this drifting buoy to help us monitor our sea surface temperatures. And what we're going to do is try to determine how rapidly the water is moving in this area. We're deploying 2 drifters today, right? One is in the channel itself, and then we'll be going past the Channel Islands, south of the Channel Islands, and we'll be deploying a second drifter. And we're trying to monitor what's happening with the California current, which flows southward along the west coast of the United States. 1, 2, 3!
If all goes well, the buoy's journeys could continue for well over a year. And as the buoys set out to begin collecting information, the Argos help launch yet another tool that scientists use to collect ocean data, an autonomous underwater vehicle, or AUV.
Here we are at the south side of Santa Rosa Island. You can see out here what we're going to take is this AUV, autonomous underwater vehicle, and we're going to deploy it here, and it's going to head out towards the south. It's going to go for about 2 hours on its mission.
Over the next few hours aboard the Shearwater, the Argos not only anxiously await to hear back from their deployed instruments, but also struggle to gain their sea legs.
So being in the ocean today was kind of exhausting, and at the beginning it was seasick, but then you get used to it, and it's a great experience because it's not just throwing an object to the ocean, it's making the difference by throwing an object that will collect data for human benefit.
The Argos' patience pays off when data comes in from the first drifting buoy and the AUV reappears.
There it is.
All right.
The AUV collects information like salinity and temperature at different depths, and scientists care about these measurements because they determine water's density and therefore the way the ocean water moves. That's because colder water is denser, so it sinks below warm water, and more saline or salty water is denser and sinks below fresher water.
So you've seen here on this 2-hour mission how the AUV can be used to measure things that are very important, such as the salinity and the temperature. And so with that, let's go ahead and check on how that buoy's doing and see if we got any new data. All right?
The information collected by all the buoys in the Global Buoy Program is uploaded to NOAA's Adopt a Drifter website, where the Argos can view their buoy's data.
Okay, Argos, we're going to take a look at some drifter data from the first drifting buoy that we deployed yesterday. That's the only data that's come in so far, but we'll take a look at a few data points to see what they're showing us. These are 3 data points when the drifter was actually in the water. And if you notice, on the y-axis, we have sea surface temperature in degrees Celsius. It ranges from 14.
Similar to the AUV, the temperature data collected by buoys helps scientists understand the ocean currents and predict climate phenomena.
So why are we studying this? Why are we looking at what the drifting buoy data tell us? It's really important as a key component of a much larger network. The Global Drifting Buoy Program is a network of 1,250 drifters that are located across our global ocean. And this is just one small fraction of that, but it provides us with a little snapshot image of what's happening here in the Channel Islands. And it plays into the big picture, giving us a better understanding of what our climate is like, because the sea surface temperatures, the ocean temperatures are so intimately connected with the atmospheric temperatures above. And there's definitely a huge link between the two. And what I'd like to do now is segue into a discussion of what happens right here in the tropical Pacific Ocean. There's something referred to as El Nino or ENSO.
El Nino is an irregularly occurring flow of unusually warm surface water from the western Pacific Ocean toward the west coast of South America. It's important to understand this climate phenomenon so that people living in affected regions can prepare for El Nino's often severe impact.
And we're going to look at this region, the tropical Pacific Ocean, which is where El Nino develops. We have cold water moving around and coming up as the cold Peruvian current off the west coast of South America. But during an El Nino year, when ENSO and El Nino develops, this cold ocean water begins to migrate westward, and it actually begins to slow down. When it slows, it can sometimes even reverse in its path, bringing this warm pooling of water that typically tends to be found in the Western Pacific, that begins to migrate eastward. And so we no longer see such cold waters off the western coast of South America.
People all over the world rely on the climate trends during the more typical non-El Nino years. So when El Nino disrupts those trends, people's livelihoods can be affected. And such is the case with the fishermen of Peru.
And the Peruvian fishermen are supported because of the anchovy industry and the fishing industry. That warmer water moves in, and those anchovies either disappear, they migrate elsewhere, and the fishing industry for the people along South America can actually collapse.
El Nino is just one example of how a climate event in a particular region can be felt across the globe. After an expedition of deploying and analyzing data from highly advanced technological instruments, the Argos returned to the RV Shearwater with Stanitsky and Adler to review their work.
Thank you so much for being part of this climate mission. That whole climate system and Earth system, it relies on each one of us, and as our global population continues to increase, we each really make a significant impact, and we can do so in a real positive direction. So all the best with all of your future research and your future schooling, and we really hope that you've learned enough here so you can go back and make those positive differences in your communities. Thank you.
Thank you.
Thank you.